Hi, Algebra 2. This is Unit 13, Lesson 2, and today we're going to talk about population parameters. So I have a lot of these definitions already written, so if you need to pause the video to copy them, please do so. But a population is just a complete set of all the subjects that's being studied. So if I wanted to do a study on the 11th graders in the Central Islip High School, then that would be my population. If I wanted to do a study on infants would be my population. A sample is a portion of the population that's randomly selected, and that's key, randomly selected, that is used to represent the entire populations. So sometimes it's not feasible to ask everybody a question or to have everybody participate in an experiment, so you use a sample, but it needs to be random. And then here's some the population parameters or statistics that are used to describe a population. So the mean, so that little symbol there, you see that with the X with the line above it, that's my symbol for mean. Mean is the average. It's the sum of all the data divided by the total number of data. So if I had test scores, I might want to find the mean or the average. And I'm going to show you how to do this in your calculator. So this is really just a summary of some basic statistics, things that you should know, and an introduction to some things that we're going to be talking about on Monday. So the mean is the average, the sum of all the data divided by the total number of data. Median is the middle. You have to arrange the data from lowest to highest, but your median is your middle score. Sometimes I actually like the median the best when I'm looking at test scores because I can see where the middle, where most of those people, their scores lie, where the mean can be, if there's a really low score, like if maybe like two people didn't take the test and there's 2 zeros, then that brings the average down quite a bit, where the median will be more stable at what the middle, what those people are doing. The mode is the most. It's the data with the greatest frequency. All right, difference of the means, all you're going to do is subtract the means. Sometimes we have the mean for the population and the mean for a sample, and we might just have to subtract them. Population proportion will be something that will come up in another lesson as well. It's just a fraction of the population that has a certain characteristic. Standard deviation, that's what we're going to be talking about in the next two lessons. So the standard deviation is the measure of how spread out the numbers are. Basically, how far the data is from the mean, right? If I have a mean of 80 for a test, most of my scores, are they between 70 and 90? Like, are they clustered around the mean? Or do they range more from, 20 to 100? So the standard deviation is how spread out the numbers are, how far they are from the mean. There's two types of standard deviation. We have the population standard deviation. So it's this little symbol right here. It almost looks like an O, but it has a tail coming off the top. That is a Greek letter. We pronounce it sigma. All right, so sigma, that's the population standard deviation, the standard deviation of the entire population versus the sample standard deviation. Okay, so two types of standard deviation. And then this is stuff that you probably did in statistics, if not in algebra back in middle school. The lower quartile, Q1, is the 25th percentile. The upper quartile, Q3, is the 75th percentile. So basically, that doesn't mean that you got a 75, but if you take a standardized test and your score is in the 75th percentile, that means that 75% of the data is at or below that score. The range, I'm sure you remember that. The range is the difference between the max and the min, so the highest score and the lowest score. The interquartile range, that's the difference between the two quartiles, so Q3 minus Q1. Let me just add a 1 right there. So basically, that's your middle 50% or so. Outliers are extremely high or extremely low data relative to the rest of the data. Okay, so most of you people got, on the test got 70s, 80s, 90s, and then you had one person that got a 10 on the test. That's an outlier. It's either extremely high or extremely low data. All right, now I can actually use a calculator to find all these population parameters. So the way that you're going to do it is there's a stat button. All right, you have to put the data into your calculator. So to put the data into your calculator, you're going to hit stat edit, and then you're going to put the data in L1 and then the frequency in L2. So if all of my data just occurs once, then I'm just going to use the L1 column. But in the example that I have right here, I have multiple scores that occur multiple times. I only have to list each of those scores once, and then I have the frequency. So I hit stat and edit. I put the data in L1 and the frequency in L2. And then to find whatever statistics you're trying to find, you're going to hit stat again. But this time you have to scroll over to the calc button, stat calc 1, and then you're going to have to enter in L1 and L2. So I'll do it on the calculator I have here, or at least we'll try and do it. So the way that you have scores on a certain test, and the way that you fill out this frequency table, my lowest score is 70, and then 75, and then 80, 85, 90, 95, 100. Okay, the way that I like to do it is I like to make little tally marks next to each one and I go through it one by one. So 95, see how I cross it out? And I write a little tally mark. 90, 95 again, 75, 90, 80, 95, 90, 95, 85, 90, 80, 75, and if you go through them one by one, then you won't miss any. 85, 70, 85, 90. So now the fifth one, I put a line like this so that I can easily count. 100, 90, 70, 85, 85, 80, 70, 75, 95, 100, 85, 100, and 75. So I got 3 scores that are 70, 4 scores that are 75, 3 scores that are 80, 6 scores that are 85, 6 scores that are 90, 5 scores that are 95, and 3 scores that are 100. All right, so now I'm going to put all of these numbers into my calculator. So this is going to be my L1, this is going to be my L2, and I actually already have the answers from my calculator right here, but let me show you how you put them in. So I'm going to hit I'm going to get my calculator. Where's my calculator? Calculator. And then L1, so let me start from the beginning. So let me quit this. So I hit the stat button, okay, and see how it's on edit, and I'm going to hit enter. Then L1, my scores are 70, 75, 80, 85, 90, 95, 100. Okay, and then I hit my right arrow. So now I can put all the frequencies in. So 3, 4, 3, 6, 6, 5, 3. Okay. So now all my data is in. So I'm going to hit the stat button again, and I'm going to scroll over to calc, and I want number 1. So 1 says 1-VAR-STATS. Now, L1 is my list, so that came up already. Now my frequency list, that was L2, so that I have to input. So if you see above the stat button, it says in blue list. So I'm going to hit second, list, okay, and I want L2. So I just scroll down to L2, it's highlighted in pink. So now I have L2, and then I'm going to hit enter. And then all my scores are right, all my information's right here. So the mean, that's the X with the line over it, that's 85.8. Then some of these I'm not going to even use. That's the sum of the mean, the sum of the scores, the sum of the scores squared. So S of X is my sample standard deviation. And then that sigma, that's the one I actually want. So I want this standard deviation that we should use for this is the population, because we didn't use a sample. We used the data from the entire population. So I want the population standard deviation. N is the total number of scores. I have my minimum score was 70, quartile 1 was 80, the median was 85, the quartile 3 was 95, and the maximum score was 100. So now on my paper, they just asked me what the mean was. So the mean was 85.8, okay? The median was 85. The mode, there were two modes. Well, the mode I didn't find from my calculator. The mode is right here. See how both of those occurred 6 times? So there are two modes, 85 and 90, right? We don't really use mode too much. And the range is the highest score minus the lowest score. So the range is 30. That's how much the scores range from. Now, which standard deviation should we use? We should use the population standard deviation. This is not a sample. The data is the entire population. Okay. All right. So we're going to try one more together. So I have to get rid of all that data was in my calculator. So I'm going to show you how to clear the list. All right. So second problem, all 18 students in Mrs. Smith's class took a quiz with the following results in ascending order listed below. So the results are going from lowest score to highest score. Use your calculator to determine the values of the data below. All right, so I'm going to go back to my calculator. Now I have all that information. If I hit the stat button and edit, all those numbers are there. I don't want to go through and clear them one by one. So one way to do that is you're going to hit stat, and you're going to, I don't want to hit second. I don't know why I did that. We're going to hit stat and see how number 4 says clear list. So I can clear the list, but I have to put in the list I want to clear. So I just hit second and list, and I'm going to clear list 1, cleared. And then I got to do the same thing, go to stat, and I got to clear list 2, L2. So clear list, and I'm going to hit second, stat, and I can put in the list that I want to clear. All right, so now when I go to stat and edit, it shut off. If I go to stat and edit, all right, I don't know why it didn't clear. So if you do that on your regular calculator, that should all clear. Not sure why this didn't clear here. Let me try one more thing. So let me here clear. Oops, I don't know if that worked either. So as you guys know that the calculator on your, let me just second mem 712. So another way to do it is just to reset the whole calculator. So I just did that. But the first way that I told you should work if you're using a real graphing calculator and not this one that's on your phone or on my iPad. So now I got to put in the second problem that I'm doing, all right? So I'm not going to use a frequency for the second one. There are 3 scores that appear twice, but I don't need to be bothered with a frequency. I can put all of my scores into L1, and that's completely fine to do. So, oops, I didn't hit enter for some reason. All right, so I got 56, enter. I don't know, my calculator's not working right now. But I can talk you through it. So if you, I'm not sure why the enter button's not working. If you put all of that into L1, so 56, 68, 72, 72, 75, 78, 80, 84, 84, 85, 88, 88, 90, 93, 95, 99, 100, and 100. So you put all that in, and again you hit the stat button, and then you go over to calc, and you hit enter. Now this time you just use one list. You just use the L1. So if the L2 shows up on your calculator, you need to get rid of that for the frequency. All right, so I'm going to just go back and I'm going to put in the numbers that we get. So the mean to the nearest hundredth, if you did it, should be 83.72. All right. The median, 84.5. So that's because there's actually, these are the two middle scores right here, so I have to take the average of them. But your calculator gives all this information to you. You don't have to think about it. The range you do have to do, so it's this highest number minus the smaller number, so that's 44. And again, which standard deviation should we use? We should use the population standard deviation. All right, it's all the scores. This is all the students' scores, not just a sample. Whoops. Scores, not a sample. What is the standard deviation to the nearest tenth? And again, I got that right from my calculator. So it's like that O with the little tail, sort of that sigma. The standard deviation is 11.7. How do we interpret the standard deviation? So it's on average, the data is 11.7 away from the mean. On average, a data point lies 11.7 away from the mean. Okay. This is the new stuff right here, G and H, and this is what we're going to be continuing with on Monday. So this is important. This is more of what we do in Algebra 2 than anything else I talked about in this video. What percent of the scores were within one standard deviation of the mean? So here's what you're going to do. You're going to take the mean and you're going to add one standard deviation. And you're going to take the mean and you're going to subtract one standard deviation. All right, so let's do that. The mean is 83.7. And I'm just going to write one decimal because the standard deviation just has one decimal. I'm going to add 11.7. So 83.7 plus 11.7 is 95.4. And I'm going to take the mean, 83.7, and I'm going to subtract 11.7. And that gives me 72. So all the scores that are within one standard deviation of the mean, I want all the scores between 72 and 95.4. So I'm going to go in and count them up. So all the scores between 72 and 95.4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 of them. There are 13 scores and there's 18 scores total. So if I put that into my calculator, what percent? 72% of the scores fall within one standard deviation. Okay, so that's a lot of the scores. 72% of the scores fall within one standard deviation of the mean. So I take the mean, I add one standard deviation, I take the mean and I subtract one standard deviation, and I want to know how many scores fall between those two numbers. Now I'm going to try it one more time, but this time I'm going to do I want to know what percent of the data is within two standard deviations. So I'm going to take the mean and I'm going to add two standard deviations. And I'm going to take the mean and I'm going to subtract 2 times the standard deviation. All right, so the mean is 83.7 plus 2 times the standard deviation, which is 11.7. So 83.7 plus 2 times 11.7 is 107.1. And 83.7 minus 2 times 11.7, that's 60.3. So I want all the scores that are from between 60.3 and 107.1. All right, so let's go up here. All the scores that are between 60.3 All right, so 68, 67. All right, so I'm checking them all off in purple now. Basically, it's all of them except for the first one. 56 does not fall within 2 standard deviations of the mean. So 17 out of 18, and if I do that in my calculator, that's 94%. 94% of the scores of the data falls within 2 standard deviations. So that's what we're going to continue with on Monday. We did not do exercise 4 in class, all right? But we did do, I don't know why this is called 3. This should really be 5. We did do this last one just because it's really simple. A questionnaire went home to all juniors concerning their ability to bring and use mobile devices at school. The questionnaires constituted a census. Now, that's because it's going to all the juniors, not just a sample. Of the 742 juniors, 564 of them reported having web-enabled mobile devices. What was the population proportion for web-enabled devices? So the population proportion is very easy. I'm just going to I'm going to represent these numbers as a fraction. So 564 over 742. And that's equal to 0.7601. So there it is as a decimal. If I wanted to have it as a percent, I can just move my decimal over 2 places. It's about 76%. Okay, so that's the proportion. I'm just writing those numbers as a fraction. And that's it.